Welcome to the Endo meeting on Wednesday, June 4th of 2025. Take it away, Eric.
Ooh. Right. I will hold the floor for just a brief second before handing it off to Chip, probably, um, because we talked recently. It was requested by Kumavis that he would like a SwingSet architecture deep dive. Like, how does this work? What is its relation to LiveSlots?
And Chip
Uh,
was given absolutely no notice.
that is not true. Although I did mention briefly that this may
Kind of
happen.
true.
It's kind of true. Okay, it's kind of true. Uh, because yeah, so Kamavas would like a to understand how SwingSet works and its relationship to LiveSlots. And then we would also like to take that opportunity of looking at that to talk about, what is the like how does the OCap kernel make use of LiveSlots and how is it different from SwingSet? And so that is the proposed topic for today's meeting. Um, if the OCap kernel team stands ready to address it.
I can extemporize at will. Whether the results will be um, helpful is up to others to be.
I can give some context on where we're coming from.
Mhm.
Um,
Um, if it was Kumavis who wanted to know this, I'm much better at answering questions than I am at just sort of expounding in an open-ended kind of way. Um,
so let me give some background on what I suspect Kumavas wants to learn. Um, the Kumavas has taken up the mantle of implementing OCapN, right? And
I can, yeah, I mean, I can contrast.
well,
Uh,
basically where we are is that we have SwingSet, which is SwingSet and LiveSlots, and we have Endo CapTP, which branched off of those before they developed virtual and durable capabilities. And then we have this OCapN implementation that Kumavas is writing, which is branching off of that branch and adding three-party handoff capabilities. And there seem to be like three tiers of feature that an OCap kernel might implement, and it would be nice to have all of them. One is virtual and durable capabilities, and then the other is three-party handoff, and then the other is having a routing substrate that does not require the routing substrate to materialize the messages, just transforms slots and moves messages from socket to socket. And
so
yeah,
so it may be useful to compare and contrast the OCap kernel and um, with SwingSet because OCap kernel is largely sort of the conceptual child of SwingSet, and in parts the literal child of SwingSet, in that we are using LiveSlots verbatim. Um, uh, but one of the things which is interesting, and not touched on any of the three things that you just mentioned, is that the OCap kernel is subject to a different set of uh, constraints and requirements than SwingSet is. And most of that relates to um, uh, the role of non-determinism and synchronicity of execution, because SwingSet is attempting to provide a medium for multiple validators to all replicate the same computation and get the same answer. Um, Whereas OCap kernel has no such limitation or requirement. And that means that the OCap kernel is able to relax some of the things that SwingSet does to ensure that everything happens the same way every time. Now, there is a lot of sort of benefit from a security and a software engineering point of view from being able to have control over how non-determinism, seeps into the computation, in particular for doing things like replay for various reasons, and not just for persistence, but also for things like debugging, although we're not currently doing that. But since we're kind of taking SwingSet as our jumping off point, we're following a strategy that's sort of a successive relaxation of some of these constraints. The thing that SwingSet and OCap kernel have in common that contrasts them with some of the earlier implementations of some of these same ideas, notably the things like like the E system and its relatives descended from the work that we did at Electric Communities, is that in that world, sort of each computer was considered an independent agent with a one-to-one relationship with any other particular VAT that it was in communication with. And so each, you could conceive of each VAT as its own independent computer. And that meant that the mapping tables that that the system had to maintain to take references from VAT A and translate them into that are contained by a message from, say, at VAT A to VAT B, translate them into references that could be understood by VAT B, required a CLIST table, mapping table, to convert those references. And so for every pairwise relationship between two VATs, there had to be a set of these tables, which means that for a hypothetical population of n VATs, which could be arbitrarily interconnected, in the worst case, you had to have n squared sets of mapping tables. Whereas in the case of SwingSet or the OCap kernel, where a lot of the relationships are between VATs that are all together being managed by the same kernel, the kernel, you map from VAT space into kernel space, and then from kernel space, from sending VAT space into kernel space, and then from kernel space into receiving VAT space, or back. And so that means you only have to have n sets of mapping tables. And so it is considerably less expensive in terms of the space overhead that you need to maintain for a given set of relationships. Now, I'm in the middle of working on getting one set of VATs managed by a kernel talking to another set of VATs managed by a different kernel with a connection between them, and you have that same sort of n squared issue with respect to the relationship between kernels. But the hope there is that the kernel is fronting for an arbitrary number of VATs, and so the n squared explosion isn't in practice quite as bad. I don't know where this goes, but this is just some points of interest.
I want to express some skepticism about what the n squared cost is and why it's much less bad than it sounds?
I can probably anticipate some of that. I suspect most of it has to do with the fact that the number of references that get stretched across the network between any two random VATs is, in the typical case, relatively small.
So all of the references that get stretched between a given pair of VATs all go over one connection. So
Right.
So what you're talking about is the n squared connections, assuming that you've got, assuming that for each of the pair of VATs, there is a reference going directly between that pair, which means you already have at least n squared references. So, right, without n squared references, you
Yeah.
can't.
Okay. That's a fair point. That's a fair point.
Okay.
Although, every time you have sort of administrative overhead,
Yeah.
there's a multiplier there.
But that's not a complexity measure issue.
That is true. Yes.
And furthermore, there's an interesting well, yeah, it's unlikely that the network is going to be fully connected, and actually having a kernel here or a comms vat here and all of these relays um, means that you're going to have a communication bottleneck, that all messages between all local VATs are going to be relayed through the kernel, and then any message that's from any VAT to any other VAT out of the network is going to also have another couple of relays. And these relays are expensive, and this motivates the issue I'm showing.
It's probably another thing worth pointing out as what's an emerging difference between OCap kernel and SwingSet is we don't have a comms VAT. We just have connection. The kernel itself, treats a connection to another kernel as if it were like just another VAT.
Well, hold on. Are the reference to another kernel on a machine where the machines are mutually suspicious of each other?
Yeah. Yes. They basically, if you have a bunch of VATs which are all being managed by a kernel on some other machine, the fact that it is one VAT or 1,000 VATs, from your perspective, is irrelevant because you only have that kernel's word for it as to which things are in which VATs. So you have to kind of treat them as a single unit of untrusted stuff.
Okay, but I'm reacting to the claim that you don't have a comms VAT.
We don't have a comms VAT.
Yeah, I think that it is absolutely possible to unify the kernel and comms VAT. And the only difference in this imagining of the topology, the kernel sees VATs as locally assigned numbers and doesn't have to concern itself with like the public key of a peer.
Right.
And you can unify these by just having the kernel be aware of its own public key, essentially, and making and being or the public key or whatever the VAT and the local whatever the full Swissnum VAT identifier is becomes important.
Right.
So yeah, and there's some complexity that gets you can consolidate them, but some complexity gets entrained for identifying VATs in a more general.
Yeah, it's just that it turns out a lot of the machinery that you would need inside the comms VAT for talking to all of the various things it talks to, and the machinery that you need inside the kernel to talk to all of the VATs it talks to is to a significant degree the same machinery.
Yeah,
but we only need one of them.
I'm the thing that they have in common is that they are relays.
Yes.
The special thing about relays is that it's a CapTP implementation that doesn't have to reify the messages, which is important because relays need to be fast. Um, and that may inform a whole bunch of design decisions for OCapN as a wire protocol. My argument that I'm going to pitch next week is, I may have time to pitch next week, is that um, not only should the body of a message be ignorable to a relay, like we have the body slots abstraction. OCapN does not yet have the body slots abstraction. I'm going to argue that it must.
Yeah.
And I might go so far to argue that the slots abstraction needs to be sufficiently abstract. It needs to be sufficient that, and this would be a stretch, but relays can perform much, much more quickly if the expectation is that you're going to take bytes off of a socket and write the same bytes lightly modified to another socket. And we're doing the slot to slot transformation in these relays. It may make sense to oblige the slots to be fixed width so that they can be punched in place, overwritten in place as part of the transform.
I'm not sure I followed what you said there by fixed width. What do you mean by that?
Yeah, when I was at Uber, we did a wire protocol called T-channel, which was a message framing protocol, and the constraint was we were writing relays, lots and lots of relays that had to be very, very fast, like 10,000 messages per second fast.
Right.
And in order to do that, HTTP can't do that. But
right. This is why, like, packet switches for like TCP/IP,
yes,
leverage the fact that all of the headers have all of the addresses in known fixed offsets from the start of the packet.
yes, exactly. And we could do that. We could conceivably do that for the slots.
Well, the slots right now, yes, and that's, I think, mostly a matter of choosing the wire representation, because the slots in the serialized form that we're using now is a serialized array, but it is an array, which is to say it's indexed by position. And
It's a variable width array, but for
what do you mean a variable width array? Do you mean a variable length array, or
yes. Well, the number of slots varies from message to message.
Yes.
But over the course of transforming a single message, the ingress message and the egress message will have the same number of slots.
Yes. Well, if you were, for example, to have a representation which put the slots array as the first part of the message, that you would need a little bit of safety checking to make sure you didn't overrun that end of that array, but there wouldn't be necessarily any particular additional overhead, I should say, associated. Hang on a second, somebody is really trying to get hold of me about something stupid.
The slots, the values representing the slots themselves are also variable width, though.
You're right. That is right. They're strings currently. It is an array of strings.
Yeah, they would need not to be strings.
They don't need to be strings. They're
the strings are encoding essentially an enum of what category of reference they are, and then potentially a positive or negative number within that category.
Well, the positive or negative is just another bit of
the category, yeah.
Of the category. This is actually an argument that I would have with Brian occasionally. Actually, I'm not sure it was an argument I was having with Brian or an argument I was having with Mark. Of having the numeric part of the reference string be represented internally, whether you were representing it internally as a number or as a big int, because in order for the big intness to matter, you would have to be having upwards of some astronomical number of references before you were in danger of running out of address space. And as a practical matter, I always thought that it was, perfectly fine to just use a number for that. And in this case, for something where you really cared about the binary layout of the representation, you really would want to use something like 32-bit or 64-bit integer, fixed size values. And yeah, you'd want to program some kind of safety check for overflow, but since you're never going to encounter overflow in practice, I think that's a reasonable thing to do.
It's also not necessarily the case. You can still get, like, we could have it so that we just have two, like, even within the variable width even within a variable width slot representation discipline, there are potential optimizations just by having the slots and the body be in separate binary subsets, and then so that you can just mem copy or write, or just write the body out, and you can reconstruct the slots.
And I think this has in part not been material up until now, and perhaps not for a while yet, simply because although the overhead of doing these things this way is reasonably substantial, it's in a context of a whole bunch of other things that are all kind of slow and not super efficient. Anyway. And so if you were to optimize the hell out of this, it wouldn't necessarily make a big difference in the grand scheme of things. And I'm totally on board with sort of sneering at the cult of fast, until we're in a situation where that kind of performance becomes observable, at which point, at which point we can declare victory.
I think that OCapN is the place to start caring about this, because it is intended to become a standard that is long-lived and WOB scale, if you will.
Mm-hmm.
But yeah, it's right that it is absolutely right that we have deferred that concern. And even OCapN has deferred the concern of separating slots from body, which is, that is, I think, the fundamental, like, even Agoric and Endo do not punt that particular concern. Though I think that we have not yet significantly benefited from the separation. I think that it's around the corner, especially if OCapN is around the corner, because OCapN has a binary format. It doesn't suffer from Hilbert hoteling when we.
So one question there is in the context of the entire rest of the system, of which whatever the protocol representation is a component, how close are we to having this matter?
So on Sprightly side, they're hauling OCapN over WebSockets from a web page,
right,
to a relay server, because they can't do anything without a relay server.
That is what we'll be doing as well.
Yeah. Once you have a relay server, then this becomes a concern. You're going to
well, except at that point, that relay is a dumb relay. That relay is not doing any kind of translation. It's just take the thing from here and put it over there, because all of the IT people of the world have screwed up the normal operation of TCP networks.
Yeah. Let me channel some thoughts Kumavas sent my way. They're more or less in the same architectural direction as unifying kernel and ComsVAD, but what I tried to impress upon Kumavas in our conversations about this architecture is that the ultimate goal, the ultimate invariant of any architecture, any topology, for these relays is that they have to preserve what Mark has called grant matching, I believe. Grant matching is the right term, Mark? Chip?
Grant matching equality.
Grant matching equality. That is
I was going to say we're talking about our stand-in for distributed EQ.
Yes. The idea is that if you have a remotable, a target in OCapN parlance, on Avery, and that target has been handed off to any other VAT via any other VAT, that they converge on this and on from to an equal value in Avery. So VAT 1 and VAT 2 can talk about Avery's um, foo widget. Foo Avery's got a widget. VAT 1 and VAT 2 can both have references to that and talk about it, and they will and the references in VAT 1, VAT 2, and Avery will be will pass equality tests locally, regardless of what path those references traveled. And in order to do that, you have to have a VAT table that is preserved either by the comms VAT or the kernel, or in composition with these two, such that these targets can be uniquely identified. And in the distributed system, the key that uniquely identifies an object within a particular VAT includes the identity, the unforgeable identity of the VAT in the global network. And if you have something like LiveSlots, where there's LiveSlots in ComsVat, the kernel in this diagram does not need to be aware of the globally unique identity. It only needs to know the local VAT number, which can be much shorter.
Yeah.
And the comms VAT then takes on the concern of having of keeping track of tables with much fatter keys. The What Kumavas observed is that we can do that without creating a communication bottleneck through this hub and spoke architecture, by moving file descriptors around among the VATs and having reducing the role of the comms VAT and kernel VAT to uniquely identifying VATs, so that there's a point to uniquely identifying VATs and vending out message ports or pipes, whatever you are.
I think you're completely losing me here. I mean,
Okay.
what are you even talking about?
So basically the architecture that Kumavas proposed to me would look like, for every peer, and only peers are uniquely identified by like an unforgeable universal identifier. And in OCap,
Right.
that's a public key.
Right. Okay. Yeah. With you so far.
It is possible to preserve grant matching equality if for every peer there is a relay.
What do you mean?
The kernel is a relay, and then there's an Avery relay, a Bobby relay, and a Charlie relay.
Okay. Well, I'm
not understanding the
I'm not understanding. What are Avery, Bobby, and Charlie? What are they?
These are peers.
What are they? I am a kernel.
Mm-hmm.
What is my mental model of the thing at the other end of the connection?
Each of these is a microcosm of this diagram.
Right. Essentially, the box that's labeled Avery could be replaced by a box labeled Avery kernel, and then Avery VAT 1, Avery VAT 2, Avery VAT 3.
Yes.
Okay. All right. That is how I've been thinking about it. But the fact that behind Avery or whoever there could be an arbitrary number of VATs, is their business and is opaque to me. And to the extent that they choose to tell me about that, it's like, okay, if you say so.
Yeah, so the unique identifier for a VAT in this distributed model is the public key and a number, a VAT number managed by the kernel at Avery.
Well, at that point, are you even uniquely identifying VATs remotely, or are you just identifying objects? In other words, if I have some object that I talk to by talking to Avery,
Yeah.
and it's in
Yeah.
Avery's VAT number 1, and I have some other object that I, talk to Avery about, and it's in Avery VAT 2, the fact that those two objects are in two separate VATs from each other is neither something that I can know for certain sure or take advantage of knowing, nor should I care.
Yeah. So, so if there's Avery VAT 1 over here who wants to talk to kernel VAT 1, the message
Well, except that VAT is a sort of execution encapsulation abstraction. All of the actual communications are between objects. So I never really talk to a VAT, except insofar as there's some object, which is, for example, we have this notion of a VAT root, but that's a kind of arbitrary.
Let me just put it this way. Kumavas is confident that if a message needs to pass from Avery VAT 1 to Bobby VAT 2,
right,
that could be conducted over a unique file descriptor pairwise between Avery.
Okay, I'm sorry. Avery and Avery and Bobby, was it?
Yeah, let's say Avery VAT 1.
Those are on two separate machines. There is no file descriptor that you can
Yes,
pass between them.
Oh, absolutely.
Yeah.
It's called a socket.
Not between machines, it's not.
No.
Unix domain sockets are only within a machine.
But sockets are not Unix domain sockets.
Then you can't.
Sockets in the WebSocket sense?
No, socket in the POSIX sense. POSIX.
The POSIX socket, you cannot pass a file descriptor.
Not a thing.
Over them.
You don't have file descriptors that can pass between machines. That's not a thing.
Well, yeah. Okay, fair enough. You cannot pass a socket over a network socket. Let me put it this way. What you can do is have a process on your machine that is able to introduce a Unix domain socket locally to your VAT and enable messages to be pumped through a network socket.
Right, except that the expensive relay operation is not the interprocess communications overhead. It's the network communications overhead.
Yeah, and and there are a lot of different arrangements for that, but all of them amount to some combination, some trade-off for the head of line blocking problem.
Right. State the head of line blocking problem.
The head of line blocking problem is that messages that are being multiplexed between multiple senders and receivers through a single TCP-like socket that has a buffer are constrained by the sliding window of the messages that pass through that buffer. And even if they are independent messages that could be delivered out of order, they must wait for all messages that were sent before them.
Well, there is, you must wait for, the transmission of the bits, but the actual delivery of the things on the receiving end those don't have to block each other. Now, currently the implementations that we have do, but once again, I think that's mostly inherited from the need to have support replicated computation. But I've been doing a lot of thinking the past year about how loosely coupled can we make the VATs, and how free and independent can they be in execution.
Yeah, OCapN makes, I think, the wise choice of just leaning hard onto FIFO for every pair of VATs.
Yes, that is that is, I think, I mean, you need to ground it somewhere, just to have some universe where it's sane and you can think about it.
Yeah, well, it's not just about sanity. It's that it's really just in my communication between Avery VAT1 and Bobby VAT2, I I do not wish to have to be explicit about uh, the causal relationship between every message between those pair of VATs. I will have to be very explicit about the causal relationship between interactions between for getting things to occur in the right order if there are more than two VATs involved. Like there will be read
Yeah,
after write hazards if I'm not very explicit about the causality I intend with using
right.
like E after. We're going to have to use E after a lot when we're doing read after write with multi-VAT interactions.
Right. Well, one question there is how much of that is a set of rules that is enforced by the computational substrate,
Mhm.
and how much of that is, um, you know,
Yeah,
things
and
you have to
there are
take
trade-offs
care
for
of
that.
in your application logic.
Yeah, if they're conjoined swing sets, then it's all implicit.
Right.
But that means that you have conjoined swing sets, which
Right.
which means you're going to move very slowly.
Right.
And so which is to say that there are trade-offs, and we need to make a system that enables both of these trade-offs to be used in the cases where they are useful and necessary.
Hmm.
The Oh, in any case, the upshot of this is if you're using this model where all of these lines are FIFO connections, it's unnecessarily constrained.
Um, this may seem like a dumb question, and it might even be one, but what do you mean by a FIFO connection?
Meaning that every message through the connection is received in the order in which it was sent. First in, first out.
Including the
Right, but there is FIFO in terms of the data communications, which is in some sense unavoidable, because whatever the bandwidth of your channel, you can transmit 1 bit per bit time. Um, but there is also the question of, once a complete unit of something is received, or enough of a unit that you can start doing something with it, which that's actually an interesting protocol design question. Um, um, how soon can you start doing something with it? Do you have to wait for everything that has come before, or can you give it to some entity that starts working on it immediately? And I don't, and which would mean that um, um, there is an ordering of the start of receipt of each message, but the actual um, um, FIFO-ness of it is, um, uh, I think, less constrained than you're making it out to be. And this is why I'm constantly touching on, do you mean FIFO in terms of the data link, or do you mean FIFO in terms of processing? So I think FIFO in terms of the data link is to, at some level of abstraction, inescapable. But FIFO in terms of processing is something where you have a lot of flexibility. And a sort of analogous universe to think about this is in something like HTTP 2, I think it is, now has the ability for request response pairs to interleave, so that you don't have to wait for the response to the last thing you sent to send the next thing.
That's HTTP3.
HTTP3. Okay. But the
and HTTP3 would be an excellent substrate.
No, HTTP2 supports that as well.
Yeah, I think it did. But anyway, I don't care about HTTP because once you've descended into HTTP, you've already given up the game. But but there is an abstraction there that these things can slide past each other in the transmission, and that's an abstraction you can maintain. But at the level at which you have an actual TCP link, those bits are going to come in the order they come in. It's just what order you choose to stuff them down the pipe you can be clever.
Interestingly enough, Quick 3 isn't TCP.
That's true. That is true.
That's actually the fundamental difference between 2 and 3.
2 and 3, yeah.
Subsuming TCP.
Yeah. In any case, I don't think we're disagreeing. I think that we agree that the FIFO delivery of messages pairwise between any pair of VATs can be enforced with a wide variety of topologies.
Yeah.
Sure. Yeah, and Kumavis identified one. It's involved, but has some of the same, the trade-offs in the topology within this message passing system all amount to what are your keys for identifying VATs at what layers, are they conflated, are they not, and
yeah, I mean the thing is that we, although under the hood you've got these sort of what for me are kernel to kernel peer-to-peer connections that are have some kind of pairwise authentication. Once you've got the communications link established, you don't need to deal in any of that. It's just this is my remote connection number 3, which is very similar to this is my VAT number 7.
Yeah, and the interesting thing about that approach is that it can be spawned off into a subprocess, and the kernel need not be in the pipeline, and then thereby take advantage of more of your CPU cores.
Well, what do you mean? This can be spun off into what is it that is being separated?
The pump for passing messages between any particular pair of VATs, even if, albeit stretched across a network, can be managed by a separate process from the kernel once that connection is established.
Yes, I'm not entirely sure what that buys you.
It's the headline blocking concern that this isn't really germane, I think.
I don't really follow how those things are like related at all.
Well, it's a matter of that if you send a very large message from a particular VAT, like Avery VAT 1 to Bobby VAT 2, those are going to share they are potentially going to share a FIFO communications channel with messages that are much smaller and much faster, and much more frequent between another pair of VATs.
This very much is like the HTTP3 example, which is this is really a question of how is the multiplexing implemented over your data link.
Yeah, exactly.
Which is a layer above the data link itself.
Yeah, we can and probably will take great advantage of like WebSockets over Quick. And if we're clever, we can avoid headline blocking concerns.
I'm less sanguine about that, having spent the disturbing amount of the past month or two immersed in the minutiae of libp2p.
Yeah. Mhm. That's another great topic, actually. We can compare notes about libp2p sometime.
My biggest sort of shock and surprise lessons from that are not actually about libp2p itself, but about the seemingly, at least to somebody unschooled in some of this stuff, completely arbitrary, capricious, and unpredictable differentiation between what kinds of things you are allowed to do or not allowed to do in various different execution contexts that exist inside a web browser. So if you're running in an iframe, or you're running in a background page, or you're running in a web worker, or you're running in a service worker, or you're running in an extension, and all of these different things, each one of them has its own set of things that you are or are not allowed to do. And so we've had to do an enormous amount of really annoying stuff so that the things you're not allowed to do, you have to have a neighbor over there who's in a different kind of context who's allowed to do those things, and you have to communicate back and forth to kind of share. And it's like
Yeah.
what is it, the Norns of Norse mythology, um, were like, they're like, between them they had like, I forget what it was, but one eye and one tooth and one something that they had to kind of share back and forth in order to get anything done. And I suspect if I were fully immersed in the world of whatever reality people who do web browser stuff live in, I would eventually develop a mental model of why you can do this thing in this context and you can't do it in this other context, but it's annoying as hell. And having had to expend ridiculous amounts of time and effort coping with it.
Yeah, I think that answers questions not about live P2P.
Yeah,
Just
yeah. But in fact,
germane.
the stuff that you need to be able to do, the thing that you really want to be able to do is listen for an incoming connection. And in order to do that, you have to get around network address translation hoo-ha. And that means you have to have somebody outside of you to do that. And the way you get to do that in a web browser is through basically misusing WebRTC, and which is, I don't know, the whole thing is just crazy. I mean, it's like, what are these people thinking? And you can like, well, you can't use WebRTC from a web worker. On the other hand, if you need to talk to a database, well, you need to be in a worker in order to be able to do synchronous file echo. So it's like, it's just insane. But I digress.
I've been in there. I've been in there. I know what you're talking about.
And it was like,
and I mean, and then when you start talking about extensions, like the web has these abstractions for message ports, and then extensions have their own message passing abstraction.
Yes, I want to, I know. If there were some place where all of these people met, except that there isn't because it's all done distributedly over the web mostly. You want to go into a meeting of Whatwig or some other, whatever the entity, the body is, and just scream at them. I'm sorry. I'm now into ranting mode. We should talk about something productive.
Let's summarize what we think we've answered for Kumavis. I think that what we've answered from Kumavis is that the topology of the OCap kernel unifies kernel and comsvat into a single entity.
Yeah, I don't think of that as nearly as fundamental as you seem to. I just found that the comsvat was just like this unnecessary abstraction. Like, why do we even have that?
Which is to say that in the OCap kernel, VATs are uniquely identified on a global. In what are the keys? What are the keys that identify a VAT in the OCap kernel? What do they consist of?
V1, V2, V3. I don't understand what's.
And so if there's a VAT from a neighboring kernel, how are they?
Oh, that's remote. The kernel is not aware of VATs in remote kernels. It's aware of remote kernels. Because its relationship is not with the VATs. Its relationship is with the remote kernel.
Okay, so it's the comms VAT and kernel conceptually are in the same VAT, and they are separate entities. So you have your kernel, and is the idea that the kernel is at the hub and treats other kernels as equivalent to other VATs?
Yes.
In their different key space. So it's
yes.
like K1, K2, or
yeah.
Okay.
Yeah, that's exactly right.
Okay, so there's a kernel that has a key space for local VATs and a separate key space for remote kernels, and they are treated as equivalent for the purposes of message relay.
Yes. Yes.
All right. I think that's a good answer for one question anyway. How maybe Kumavis wants to know how you're cryptographically verifying the identity of a remote kernel.
At this point, I am taking libp2p's word for it. And this is a divide and conquer exercise.
Yeah.
Which is, I got to get the basic machinery working, and then we can stop and ask the question of, is the underlying peer-to-peer authentication machinery that this particular substrate provides sufficient to the task? My sort of 50,000 foot view take on it is, yeah, it's fine, but I'm not spending a lot of time worrying about that question yet.
Have you yet worried about third-party handoff?
No.
Okay.
Third-party handoff seems to be one of those seemingly really important things that is a can that we've been able to kick down the road indefinitely. And so my short-term strategy of the moment is to continue kicking the can down the road.
Okay, I think as a separate Endo project, we need to not do that. One of the consequences at Agoric is that we've fucked over our architecture in order to keep working around the absence of three-party handoff. It's one of these things where instead of putting the engineering effort into doing the right thing, we've put 10 times more engineering effort into working around the fact that we have not yet done the right thing.
That's interesting because the fact that in the Agoric world, everything is executing through a single kernel.
That's exactly right.
Basically it means you don't really need that. And the complication is what happens. The complication is what happens when you introduce connections to remote kernels, which was not a thing that we, at least in my tenure at Agoric, we ever got around to. And it may be that that's the piece that is needing to be brought into the story. Not so much third-party handoff, although third-party handoff may well be a necessary component of that.
Well, that was the thing that kept postponing doing multiple chains.
Ha ha. Okay.
If we
Yeah.
had if we had gotten three-party handoff figured out and done, then we would have proceeded to have a multi-chain world.
Okay,
Oh,
that makes sense.
in any case, this is the thing I like about using OCapN in particular as a focal point. It forces us to consider some long-term thinking. And they have a proposed solution for three-party handoff that we need to iterate on and become experts on. Yeah.
Yeah, I mean, this is one of those.
They have a working three-party handoff mechanism.
Yeah. I was gonna say we did three-party handoff at Electric Communities. I remember doing it, and so this is kind of fallen into the lost technologies of the ancients bucket.
Yep. The thing that Brian made me appreciate is that conventional blockchains are hard to bring into a three-party handoff mechanism because of the issue of naming the blockchain.
Yes, it's another manifestation of course, having a single global namespace is useful. That's why we have so many of them.
I certainly agree with that sentiment, but I'm not applying it here. I don't see the connection.
Well, if you only have one chain, then the problem does not arise. And all of these chains have been designed in a universe of assumptions that they were the only chain.
Got it. So the interchain, the Cosmos interchain with ICP, that certainly started with very much an E-inspired notion, or a VATTP in particular inspired notion of an overall multi-chain world. It's just that I suppose they don't do. Does IBC do anything about three-party handoff? Maybe it just doesn't.
I don't know. I don't know.
I don't think it does. They've got their global denom concept,
which relies on global namespaces, right?
Yeah.
Right. The assumption is Cosmos is all there is.
Well, but Cosmos, I mean, that by itself would not have gotten them stuck if they had the right definition of what a Cosmos is, which they started with, which is mutually suspicious instantiations of the Cosmos technology with no trust hub. I mean, with no central point of trust. I mean, that was what was inspiring to them about the E protocols, especially VATTP.
Oh, in any case, I think that focusing on OCapN forces a number of table stakes concerns to be brought up to the front. And one of them is, hey, maybe the protocol should be binary and be trivial to envelope within itself, which JSON within JSON is not, from a performance point of view anyway. The other one is, hey, three-party handoff. And the other is ensuring that our interlink is that VATs are unforgeably identifiable over the network, and then yeah, three-party hand. The only thing that OCapN doesn't force is a solution for durable and virtual, and it would be really lovely to have a unified theory.
I'm missing a step there. What do those two things have to do with each other?
Nothing other than that they probably are going to share. I assume that an OCapN implementation that's actually like a client is going to have to take these things into account. but I might be wrong. I haven't dealt
What
with
does that
it.
mean? I mean, I know we've got a lot of leverage out of the fact that in SwingSet and well in LiveSlots, a reference to an object which is just on disk somewhere and a reference to an object that's on another machine are the same. So you can just treat you know, being persistent to durable storage is just another form of being elsewhere.
Mhm.
And
Yeah, and that is the only extent to which I think that these issues are entangled.
I mean, the reason why it's useful to have that in a common frame of reference mostly comes up in the context of garbage collection.
Yeah. Yep. All right. Well, we're running over a little bit. I think that this may have been a useful conversation to send a recording off to Kumavis to.
Maybe.
Maybe. I hope that we have a better shared foundation. And see you next time.
All right.
Bye.
Ciao for now.